Hello guys, welcome to my new channel. In this video, I'm going to introduce you to a brief on the geohazard setting of Kuala Lumpur. Kuala Lumpur is the capital of Malaysia. Malaysia is located in the southeast of the Asian continent. Therefore, this region is often referred to as Southeast Asia. There are over 28 million inhabitants in the country. Malaysia consists out two parts: Peninsular Malaysia, located between Thailand in the north and Singapore in the south, and the two provinces Sabah and Sarawak, located on Borneo. Peninsular Malaysia is located just above the equator and Borneo just beneath it. The large island Borneo is shared with Indonesia. They call this island Kalimantan, and Brunei. To the north it borders the Philippines, that still has claims on parts of Borneo, via sea. The capital city is Kuala Lumpur, a metropolis with over 1.6 million inhabitants in the city center. Suburbs like Subang, Petaling Jaya, Ampang Jaya, Alor Setar and Klang are not included. Kuala Lumpur is situated in the broad valley of the river Klang, which consists of a flat alluvial plain with open-cast mining ponds. Kuala Lumpur is bounded by hills predominantly of granitic rock to the west and east and metasediments southwest. Approximately 40% of Kuala Lumpur is underlain by fractured limestone. The total area of the area underlain by Kuala Lumpur limestone is 236,827 square kilometers. The geological stratigraphy of Kuala Lumpur area starts with the older succession called the Hawthornden Formation in terms of schist overlain by Kuala Lumpur limestone and Kenny Hill Formation. The Hawthornden and Kuala Lumpur formations were subjected to the first phase of compression force that led to faulted fold limestone during the Lower Paleozoic era. The Kenny Hill Formation was recently formed from metasediments and clay slightly metamorphosed during the Permo-Carboniferous. It forms an angular unconformity with underlain limestone. The Hawthornden, Kuala Lumpur limestone, and Kenny Hill Formation were subjected to the second tectonic phase during Jurassic, leading to deformation and faulted folding of most of the rock unites. Finally, all stratigraphic successions, 3 unites, were thermally metamorphosed by granite intrusion leading to the formation of marble and schist. All formations, including granite deformed by the last phase of tectonics forming complex faulted folding, joints, and fractures, are mainly northeast and northwest in trend. These faults are tensional, wrench, and some are low-lying, because of the regional shear stress that affects Kuala Lumpur and the successive tectonic events during the Silurian and Cretaceous. They have low dipping angles range from 25 degrees to 35 degrees in east-west, west-northwest, northeast and north-northeast. Geologists, geomorphologists and geotechnical engineers are all aware of the role of geological fractures in natural resource accumulation. These geological fractures include faults, joints, fissures and bedding planes. Faults and fractures are serving as they do as buried channels for underground water movement, increasing the chemical and mechanical weathering of rocks and contributing to the instability of both hill slopes and bedrocks. Thus, these features are closely associated with the landslides, sinkholes, building collapse and earth subsidence. Surface and subsurface geological fractures and their associated karst terrain features represent a challenge for environmental and geotechnical engineers. For example, a location for the Petronas Twin Towers and Kuala Lumpur Convocation Center has been shifted 50 meters away from their proposed location to one entirely within the Kenny Hill Formation that consists of metasediments. This is due to the geological fractures, sinkholes, cavities and karst features forming an irregular surface of limestone bedrock, described as the worst terrain in the world. In addition to cavities and sinkholes in Kuala Lumpur limestone bedrock, landslides and rockfall show unpredictable environmental and geotechnical engineering problems in the adjacent mountainous areas. For example, Hillview building collapse, which killed 7 people in Kuala Lumpur, was reported due to the intensive geological fractures, steep slope and buried stream networks forming insatiability of the bedrock. Sinkholes and earth subsidence are features commonly associated with the dissolution zones, along fault zones and lithological contacts between Kuala Lumpur Limestone and Kenny Hill Formation. This demonstrates the need for a cost and time-effective tool to precisely map the terrain factors that contribute to the natural hazard and predict these events. The use of remote sensing permits the revealing and mapping of the most crucial factors that are associated with unpredictable environmental and geotechnical engineering problems such as flooding, landslides, sinkholes, earth subsidence and building collapse. Finally, don't forget to subscribe to the channel. Please do give the video a like, because that tells me you find this video is useful.